I just brought a couple of toys to show you. So one is frequently people like to ask how we came up with the design. So it's actually a lot of work. So we do a lot of digital renderings to get general themes, but we actually CNC'd machine out of foam blanks, and then took those into the field to say like, how do you like that look? What would you change? What would you do? So we really had like dozens of these lying around the office, all different shapes and sizes, different sizes. This one's size for like a rabbit or a cat.
I have a cat. I could put this on my cat.
They're animals too. You got to protect them. So and then we started printing some different designs. We had actually gone with a traditional shell and like what we call energy management system inside. So this is also 3D printed, and then we did a special surface treatment to kind of smooth things out.
Yeah, it looks really, really nice. Like it's like a really smooth gloss finish.
Yeah. So really unusual, I think, in 3D printing. But we, at the end of the day, decided the monocoque design had a lot of performance benefits. It was lighter, it was easier to manufacture, so that we could drop the cost of the thing down to the consumer. Again, trying to make this accessible. It is going to cost more than a standard helmet, and it will for some time. But I have kids. I have 2 kids that play hockey, so very sensitive to like how much parents are paying for their equipment and traveling and ice time. So anyway, so those are design artifacts. We do a lot digitally, but you guys are photographers, videographers. You understand like the way light hits things and the shape and contours. There's no replacing like looking at something physical, and we have a bunch of like clay models, but those don't travel well, so I didn't bother bringing those. But it's fun, like to be part of the design process where you see these videos of car manufacturers where they're like doing these giant clay models and stuff. And I'm like, finally, I've got a company where we've got our own clay models. We can just kind of carve it all day. But it's actually not as glamorous as it looks on those commercials.
It looks like hard work.
It's like hours of like taking these little shaves off of it, little slivers off. So anyway.
Now these are impressive though.
So yeah, we've come a long way too, because this would not rate well in protection. So. Other things were buckling systems.
I was going to ask about that.
We looked at all types of buckle systems. So we looked at something simple. It's just a clip. Like I don't know what the origins of using like a metal button that you have to kind of press and whatnot. But we looked at this like this seemed like a pretty common thing. It's used in like snow helmets and backpacks, obviously. Super simple, doesn't rust. But it wasn't that exciting. And it didn't solve the problem of the straps on the back of the head. So we looked at these magnetic attachments, which originally we were like, oh, we got to have these straps. Like, you have to secure the cage. So what if we attach this to the side and had the strap here, and it just automatically synced up? How cool would that be? But then we're like, whoa, we're thinking too hard. Like, why even have the straps at all? Why don't we just secure it as part of the core helmet? And in addition to that, you get these shock absorbing benefits because we've built in shock absorbers basically inside these hooks and things that are difficult to do with all these.
You guys have pretty much everything.
So that's that. We try. I mean, a lot of it's actually you just watch people and you're like, why are they doing that? It doesn't seem like you need to.
I get it. It's one of those things where it makes a lot of sense if you just step back and fix it.
Yeah. Also, as a parent, like, I don't know if your kids are playing hockey yet.
My 5-year-old is just starting to get into it, but I'm being one of those. I'm trying to be a little bit appreciative of how pushy being a hockey player myself can be, because I'm like, I want him on the ice, so I'm letting him kind of fall in love with it all by himself. I don't want to push him. Yeah. But he's slowly getting there. And
what's not to like? It's hockey, right?
Exactly.
So, he'll naturally fall.
Oh yeah. We spent like a few days in Finland doing nothing but playing on ponds.
Oh, nice.
In February.
That's fun.
So that's where I'm trying to capture it.
Yeah.
So we're getting there.
So I mean, how much do you enjoy like putting on his skates and helping him with the straps on his helmet?
The skates I like. The helmet is a bit long-winded. It's a bit more of a lengthy process than it needs to be.
Yeah. No. Exactly. So the energy management, what we call the energy management layer, like we had all these different foam samples. We literally like hundreds of these things, and we impact tested them all. It's all the stuff that you're used to seeing in helmets: vinyl, nitro, EPP foams. But yeah, I mean, they all same problems, like absorb sweat. Some of them get quite hard after you use it for a couple months, which
and the dirt as well.
It smells nice. Yeah, it smells really nice. Yeah, I like how our garage smells. So we We did all types of things, and I just brought like 3 different samples. So first iteration, we're like, well, what if we just like created little, cylinders, right, that helped absorb shock, and that would allow us to control different things. But thought that looked really inelegant. Then we're like, okay, well, what if we create like a homogeneous behavior, like isotropic material out of some polymers that we had lying around, and that gave a relatively nice feel. We could control the density of that, right, and therefore shock absorption. It has a nice property which it shears nicely, meaning it kind of turns nicely, which helps a lot with the rotational impacts. And we're like, okay, well that's kind of nice. So let's keep building on that. And so we did more testing. And so this is like a see-through version of the helmet. So you can see we have like a hex structure, which is space saving. You can see there's like variable density. It's a little bit tighter in some places, loose in others. You can see that there's aspects of it that are a little bit softer and a little bit harder. So this was like, I don't know, the 4th or 5th generation of the material. We impacted tested that. And then we have actually a much more sophisticated design, which is where we started using the machine learning which is in here, and it's purposely black because we're filing a bunch of patent IP on it. But
so you're hiding a lot of the tech that's
until everything is like all the paperwork is filed at least. Yeah. So
that's smart.
yeah. But anyway, I thought I'd just give you a little flavor of some of the internals and design process, because it seems like you guys like that type of stuff.
Yeah, for sure. If anyone hasn't guessed it already, we're gear nerds. I love learning about the mechanics of what makes things tick, what makes things possible, and this insight offers kind of a clear picture, or a clearer picture than you'd have without having this on why this is able to do what it does.
Yeah. So thanks for entertaining my rant on our 3 years of R&D and investment in building the best helmet possible.
I can see that this is your baby, and it looks like you're onto something that is definitely going to create a big discussion in the hockey world, and it's going to be interesting to see where this leads on. I'm super pumped to put one of those things on and try it out.
Yeah, no, as you should be. I think our intent is to raise the bar for everyone and just keep pushing the limits of what's possible. So, yeah, thanks for having me.
Pleasure. Thank you for coming.